we'll do some important problem in inequality, and this problem is basically important in IIT Joint Entrance, B.Sc, CSIR NET, NBHM, SSC, P.Sc, TIFR and BMath also. Here you will see two important theorem, mth power theorem and as well as the Cauchy-Schwarz inequality that we have already discussed previously. Now we will come to some most of problems. Here you will see all problems are important, and here you will see at least 20 most important problem in inequality. And we'll start one by one. We'll start from the first problem. Here the first problem says that if ABC are positive real numbers, then the least value of A plus B by C plus B plus C by A plus C plus A by B is, option 1 is 1, option 2 is 2, 3 is, option C is 5 and option D is 6. So now we will solve this problem. So first you will see here for question 1, we just use here the inequality AM greater than equals to GM. So in that case you will see A plus B, this by 2, this is greater than equals to root AB, and B plus C by 2, this is also greater than equals to root BC, and C plus A by 2, this is also greater than equals to root CA. And equality holds when A equals to B for the first case, for the second case when B equals to C, and for the third case when C equals to A. So now what is given here, the expression is A plus B by C plus B plus C by A plus C plus A by B. So that part must be greater than equal, A plus B greater than equals to 2 root AB plus B plus is greater than 2 root BC, and C plus A greater than equals to 2 root CA. So from that, what we can write, this is equals to 2 root AB plus root AB by C plus root BC by A plus root CA by B. Now again we apply AM greater than equals to GM for three numbers, say x1, x2, x3. These are three positive real numbers. If we apply AM greater than equals to GM, so x1 plus x2 by x3 by 3, that will be greater than equals to cubic root of x1, x2, x3, and equality holds when x1, x2, x3. Here you will take x1 equals to root AB by C, x2 equals to root BC by A, and x3 equals to root CA by B. So what you will get? So this is greater than equal 2 into 3 cube root of, that means AB by C multiple BC by A multiple CA root under CA by B to the power 1/3. So this value will be 1. So that means it will greater than equals to 6. So what you will write here? So A plus B by 2 plus B by C plus B plus C by A plus C plus A by B. This value is greater than equals to 6. And equality holds when A equals to B equals to C. Equality holds when A equals to B equals to C. So here option D is correct. This is the least value. Now we come to the second problem. This problem is very, very important. And you will see this problem is given in PSC examination and any other examination. This problem is very, very important. Now we'll continue this problem. So now we'll continue question number 2. What is given in question number 2? Question number 2, if ABC are positive real numbers and A plus B plus C equals to 1, then the greatest value of 1 minus A into 1 minus B and 1 minus C is, that is 4 value. And obviously among these 4 value, one option will be correct. But how will solve this kind of problem? So how to solve the question number 2? Here the solution, or you can consider as hints. Here A, what is given? It is given A, B, C all are positive real number, and also it is given A plus B plus C, A plus B plus C, that value is 1. So the 3 are positive real number, and the sum of this value A plus B plus C, this is equals to 1. So here you will see 1 minus A, this is equals to B plus C. 1 minus B, this is equals to C plus A. And 1 minus C, this is equals to A plus B. B and C are positive real numbers. 1 minus B is also a positive real number. 1 minus A, 1 minus B is positive real number. A is positive, B is positive, A plus B positive. So 1 minus C is also positive real number. Now we can apply AM greater than equals to GM for this 3 real number. AM greater than equals to GM. So what we will get? Here we will get 1 minus A. If we apply this, 1 minus A plus 1 minus B plus 1 minus C by 3, this is greater than equals to cube root of 1 minus A into 1 minus B into 1 minus C. Now that part we can write 3 minus A plus B plus C by 3 whole cube. This is greater than equals to 1 minus A into 1 minus B multiple 1 minus C. So equality holds when 1 minus A equals to 1 minus B equals to 1 minus C, that means A equals to B equals to C. So what is the A plus B plus? This is 1. So 2 by 3 whole cube. This is greater than equals to 1 minus A, 1 minus B into 1 minus C. So that means 1 minus A into 1 minus B into 1 minus C. This is less than equals to 8 by 27. So this is the greatest value. Here the question is the greatest value of 1 minus into 1 minus B, 1 minus C. That will be 8 by 27, and all other options are false. Now we come to the third question. The value of 1 factorial, 3 factorial, and 5 factorial into 2n minus 1 factorial. What is the value of the factorial? That we need to check, and which we, after that we will strike out which option will be correct. So for question 3, what will be the solution? Here you will just observe a very easy fact. If n greater than r, then we have 2n minus r. This is greater than n. What is r? Where r being a positive integer. So now, by using this fact, what we will do? We can write n factorial. This is equals to 1 into 2 into 3 into 4 dot r into r plus 1 into r plus 2, because r is less than 1 dot up to n. So that we can write r factorial into r plus 1 into r plus 2 up to n. And we also write 2n minus r. This factorial equals to 1 multiple 2 multiple 3 into n plus 1 into n plus 2 2n minus r. So that means you can write it n factorial into n plus 1 into n plus 2 up to 2n minus r. So from this, therefore, r factorial multiple 2n minus r factorial by n factorial into n factorial. This will be n plus 1 into n plus 2 2n minus r divided by r plus 1 into r plus 2 n. So actually from this expression what we will get? We will get r factorial by n factorial. This is basically 1 by r plus 1 into r plus 2 into n, and from this you can write 2n minus r factorial by n factorial. This is equals to n plus 1 into n plus 2 dot 2n minus r. So that you can consider 1 and that you can consider 2. Just to multiple 1 and 2. Just to multiple these two numbers, you will get this. So by 1 and 2. So this value must be greater than 1 since n greater than r. So this fraction is basically greater than 1. So that means from this expression we can write r factorial into 2n minus r. That factorial is greater than n factorial whole square. Now if r greater than n, we have shown 2n minus r, we can write this is less than n. So therefore r factorial, this is 1 into 2 into 3 up to n into n plus 1 dot r, that will be n factorial multiple n plus 1 into n plus 2 dot up to r, and n factorial equals to so this is case for n greater than r. Now actually we are continuing if r greater than n. So that we can write 1 into 2 into 3 up to 2n minus r plus 1 up to n, and from that we can write 2n minus r factorial into 2n minus r plus 1 up to n. So again from the expression, this is 3 and this is 4. Again by multiplication we can write 2n minus r, that factorial by r factorial into n factorial whole square. This value equals to n plus 1 into n plus 2 up to r divided by 2n minus r plus 1 up to n, and this value is also greater than 1. So that means from that expression we can write r factorial into 2n minus 1 greater than n factorial whole square. So putting this value r equals to 1 to up to 2n minus 1. So this is star and this is double star. So from either you take n equals to r or you take n less than r or r greater than n. So what we will get? So from in any case we get the result r factorial to n minus r factorial. This is greater than n factorial a whole square. In the both cases we get the same result. So now the putting the value of r equals to 1, 2, 3 up to 2n minus 1. What we get? We get mainly 1 factorial multiple 2n minus 1 factorial. This is greater than n factorial square. 3 factorial into 2n minus 3, that factorial greater than also n factorial square. And at last 2n minus 1, just we put the value of 2n minus 1, that factorial greater than that factorial multiple 1 factorial, this value greater than n factorial square. So just multiplying together, we get what we get? 1 factorial, 2 factorial, 3 factorial up to 2n minus 1 factorial. That whole square greater than n factorial square to the power n. So that means 1 factorial into 3 factorial into 5 factorial multiple 2n minus 1 factorial. This value greater than n factorial to the power n. So we have achieved the value. This factorial greater than n factorial to the power n. So what will be our answer? This is greater than n factorial to the power n. It is given in option C. So option C is correct and all other options are false. Now we come to the next question. Question number 4. If A, B, C are positive real numbers not all equal and A plus B plus C equals to 1, then the least value of this expression. So what is given in question number 4? In question 4, it is given A, B, C all are positive real numbers, not all equal, and it is also given A plus B plus C, that value is 1. What is the expression? The least value of the expression 1 by A minus 1 whole square. So you need to find out the least value of 1 by A minus 1 whole square. Multiple 1 by B minus 1 whole square. Multiple 1 by C minus 1 whole square. The least value of this expression. So now here we recall some basic and standard inequality. So what is the inequality? We need to prove this kind of expression. So the inequality is if A1, A2, An be all positive real numbers and A1 plus A2 plus An, that value, that summation is basically S, then S minus A1 by N1 minus 1 multiple S minus A2 by N minus 1 dot S minus An by N minus 1. This inequality, this expression greater than, strictly greater than A1, A2, An. They are basically not all equal. In that case, still inequality holds. Otherwise, if they are equal, then equality holds. They are all equal. So for this problem, for the given problem, how many positive numbers? So here we will do for n equals to 3. So in our case, n equals to 3. In position of A1, A2, A3, it is given ABC. What is our S? Our S is A plus B plus C and n equals to 3. Now we will apply the above inequality. So what we will get? We will get A plus B plus C. This is our S. So I am writing here first S minus A by 3 minus 1. S minus B by 3 minus 1. S minus C by 3 minus 1 greater than ABC. So that means, what is S? S is basically A plus B plus C, and this value is given 1. You will just see here, this value is 1. So that will be 1 minus A by 2, 1 minus B by 2, and 1 minus C by 2. This value is greater than A, B multiple C. I think we just divide by A, B, C individually. 1 minus A by A, 1 minus B by B, and 1 minus C by C. It is greater than 8. 2 into 2 into 2, 8. We just take 2 on the right side and ABC on the left side. So it will be 1 by A minus 1, 1 by B minus 1, 1 by C minus 1. This value, we need the square. So that square, that square, that is greater than 8 square. So that means 64. So the least value of the expression, so you can conclude the least value here of this expression is 64, because it is always greater than 64 if ABC are not equal. So option C is correct. All other options are false. Now we come to next important question. If x square plus y square plus z square, that value is 3, then the least value of 1 by x square plus 1 by y square plus 1 by z square. Now we are trying to solve this kind of problem. So here x, y, z are basically real numbers. X square plus y square plus z square are non-zero or non-negative real number. So now we apply am greater than equals to gm here. So what will be the value? X square plus, just take x square, y square, z square. These are the three non-negative number. Z square by 3, this is greater than equal. So no, we apply m greater than equals to hm. So that will be 3 by 1 by x square. We just consider x, y, z are non-zero. We assume this because this square value is 3. So 1 by z square. So from that you will see this expression and will get the value. So what is the value of x square plus y square plus z square? So here you see that x square plus y square z square, this value is 3. So just put the value of 3 here. So 3 by 3 greater than 3 by 1 by x square plus 1 by y square plus 1 by z square. So that means 1 by x square plus 1 by y square plus 1 by z square. This value greater than equal 3. So obviously this is the least value. So here the least value, it is, the expression is always greater than equals to 3. The least value is 3. So option is correct. All other options are false. Now we come to the next question. Here ABC, what is given here? What is given? A, B, C, all are basically positive real number, and it also given the sum of this positive real number is 3. So now we need to calculate the greatest value of a b square c cube. That greatest value we need to calculate. Now here we will apply weighted arithmetic mean greater than equals to geometric arithmetic mean. That's theorem. So we recall some basic facts. Then we will apply the theorem. So what will be the weighted arithmetic mean? So here we apply the recall. The recall is if a1, a2, an are n positive real number and p1, p2, pn are n positive rational number, then the weighted arithmetic mean will be p1a1 plus p2a2 plus pnan, that divided by p1 weight, p1 plus p2 plus pn. This is greater than equal a1 to the power p1 n to the power pn divided by 1 by p1 plus p2 plus pn. Here equality occurs when a1 equals to a2 equals to n. So now in similar way we will apply here the weighted arithmetic mean and weighted geometric mean. But before that we consider our a1 equals to a, our a2 equals to b by 2 and a3 equals to c by 3. And we are considering the weight p1 equals to 1, here weight of a2, p2 equals to 2 and p3 equals to 3. Now we apply weighted arithmetic mean greater than equal weighted geometric mean. So that means it will be 1 into a plus 2 into b by 2 plus 3 into c by 3 by 1 plus 2 plus 3. This is greater than equal a to the power 1 b by 2 whole square c by 3 whole cube to the power 1 plus 2 plus 3. When equality occurs, when a equals to b by 2 equals to c by 3. So what will be the value? This value is a plus b plus c by 6. This is greater than equals to a b square c cube. Here you will see the expression a b square c cube. From power you consider the weight. A weight is 1, b weight is 2, c weight is 3. So you know a plus b plus c is 3 is given. So you just put the value. So 3 by 2, okay, that value to the power 1 by 6. So 3 by 2 to the power 6. This is greater than equals to a b square c cube. So a b square c cube is less than equals to 3 by 2 a plus b plus, okay, sorry, it will be 6. So that will be half to the power 6. So 1 by 2 to the power 6. And here we just miss b square by 4 and c cube by 27. So this is 108 into 108. So that will be 27 by 16. Okay. So what we'll get? We'll get a b square c cube less than equals to 27 by 16. So this value is always less than equals to this value. So this is the greatest value. So option B is correct. All other options are false. So with the help of weighted arithmetic mean greater than equals to weighted geometric mean, we have solved this problem. Now we come to another important problem. The problem is, given if n is a positive integer, then which of the following inequality is true? So here you just consider, so this is the hints, or you can say the solution. Consider n plus 2, we consider n plus 2 positive numbers. So what are the numbers? 1 minus 1 by n plus 1, 1 minus 1 by n plus 1, 1 minus 1 by n plus 1. That number you will consider n plus 1 times, and 1, and 1. So that means total n plus 2 times. N plus 2 positive number we have chosen. Among these, n plus 1 times are same number, and you will apply the inequality m greater than equals to gm. Okay. In fact, all the numbers are not equal, so you will apply m greater than gm. So that means this is n plus 1 times n plus 1 into 1 minus 1 by n plus y by n plus 2. So this is the plus 1. This is the arithmetic mean that is greater than geometric mean. That means 1 minus 1 by n plus 1. This is multiple root it n plus 1 times into 1 to the power 1 by n plus 2. And you will get the result here. So n plus 1 that is discarded. N plus 1 that will be n by n plus 1 plus 1 by n plus 2. Okay. This is greater than 1 minus 1 by n plus 1 to the power n plus 1 to the power 1 by n plus 2. So I am taking n plus 2 power is that side. Okay. And you will see here. So n plus 1. So that will be n plus n plus 1. That means n plus 1 by n plus 1 into n plus 2 to the power n plus 2 minus n by n plus 1 to the power n plus 1. And from that you can simply prove that 1 plus 1 by n whole to the power n plus 1, this value is greater than 1 by 1 plus n plus 1 to the power n plus 2. This is your exercise. You can prove it easily. So here option is correct. All other options are false. Now we come to the next important problem. Here the problem is related to the mth power theorem. What exactly is said in mth power theorem, you will see here. Here the mth power theorem says if a1, a2, n are positive real number, not all equal, and p1, p2, pn are positive real numbers, and m is rational, then p1 a1 to the power m, p2 a to the power m plus pn an to the power m by p1 plus p2 plus pn greater than or less than this number according m does not or does lies between 0 and 1. Okay. So this kind of image power theorem you can apply here, or you can apply the simplest form of image power theorem easily, and you can prove it. So these are our problem, and we'll prove this problem. So the value of, if a b are positive real number, a plus b equals to 4, then the minimum value of a plus 1 by a whole square plus b plus 1 by b a whole square. This minimum value you need to prove, but before that we just recall the image power theorem. Recall, if a1, a2, an are n positive real numbers, if a1, a2, an are n positive real numbers, not all equal, and m is a rational number, positive rational, then just m is a rational number, it may be negative or positive, then the image power theorem says a1 to the power m plus a2 to the power m plus n to the power m divided by n greater than or less than a1 plus a2 plus n to the power n by n to the power m. When greater than holds, according to m does not or does greater than, if m does not lies between 0 to 1, less than if does lies between 0 and 1. So that means if we draw the real line and we put this is 0 and 1, if m lies between these numbers, in that case less than equality, and if m is here greater than, if m is here, that is greater than 1, on that case greater than equal, inequality holds. Now the problem is simple. We apply here the image power theorem for two positive real number a and b, and we can prove this problem very easily. So if we apply for two positive real numbers, so what would be the image power theorem? So the recall image power theorem for two positive real number a and b, so that will be a to the power m plus b to the power m by 2. This is greater than or less than a plus b by 2 whole to the power m, according as m does not or does lies between 0 and 1. So first you take m equals to 2, and you take two positive real number a and b. In that case, square plus b square by 2. Now if m equals to 2, 0 and 1, here this interval, if m equals to, it is outside, m equals to 2. So if it is does not lie between 0 and 1, so greater than, equality holds, it is greater than a plus b by 2 whole square. And equality holds, this is greater than equal, and equality holds when a equals to b. So now you will think, what is given the value of a plus b? The value of a plus b is 4. So you just put the value here. So that means a square plus b square. This is greater than equals to 8, because since a plus b equals to 4 and equality occurs when a equals to b. Again take m equals to minus 2. M equals to minus 2 is here. So this is also outside of 0 and 1. So again we apply greater than equality. So by image power theorem, what we will get? We will get a to the power minus 2 plus b to the power minus 2 by 2. This is greater than equal. Okay, equality for a plus b. Otherwise it will be strictly less than or greater than. So that will be a plus b by 2. That to the power minus 2. We just put the value a plus b. This is 4 by 2 whole to the power minus 2. So that means here 1 by square plus 1 by b square. This value is greater than equal half. And equality occurs when a equals to b. Now we come to the point. Now we need the value of a plus 1 by a whole square plus b plus 1 by b whole square. So that means it will be a square plus b square plus 1 by a square plus 1 by b square. 2 into 1 by a, that means is 2 plus 2. 2 into b into 1 by b cancel. So what is a plus b whole square? This is greater than equals to 8 and this is greater than equals to half plus 4. So that means this value will be 25 by 2. And equality holds when a equals to b. So these are the problems here. So the least value of this expression is always greater than equals to 25 by 2. So what will be the minimum value? The minimum value will be 25. Option is correct. All other options are false. Now we will solve the next problem. So here the minimum value of 3x plus 2y, where xy are positive real numbers satisfying the condition x square y cube equals to 48. So what is the expression here? The minimum value we need to find out the minimum value. Next question. 3x plus 2y. We need the minimum value of this. This is our question. And what is given? The given expression is x square y cube. This value is given and this is basically 48. 48. So obviously if we take x as a number, so weight will be 2 and y weight will be 3. But we need to think about 3x plus 2y. So here we will choose two numbers. One is a. This is 3x by 2, a1. And a2 is basically 2y, but y weight is 3. So 2y by 3 with weights p1 equals to 2 and p2 equals to 3 respectively. And we will apply the weighted arithmetic mean greater than equals to weighted geometric mean. So what will happen? So now apply weighted arithmetic mean greater than equals to weighted geometric mean. So that will be 2 into 3x by 2 plus 3 into 2y by 3 by 2 plus 3. This is greater than equals to 3x by 2 whole square, 2y by 3 whole cube to the power 1 by 2 plus 3. Now from this you can prove 3x plus 2y, this value greater than equals to 10. Just simple calculation and you will put the value x square y cube equals to 48. So how we achieve this value? Just you will do the simple procedure, put the value of x square y cube here and do the simple calculation. So 3x plus 2y, get this is the least value. So therefore the minimum value of 3x plus 2y is 10. So here option C is correct. All other options are false. Now we'll move to the question number 10. If n greater than equals to 2, then the value of 1 plus 2 plus 1 by 3 plus 1 by n. So that value we need to calculate. So here you just use the simple inequality. You take number 1 to up to n. This number you will choose. These are the positive real numbers. In fact, they are the natural number. And we will apply AM greater than HM because all numbers are not equal. Equality sign not holds. So 1 plus 2 plus n by n. This value greater than 1 by 1 plus 1 half plus 1 by n. And you will see the result easily. What will be the result? So here this value is n into n plus 1 by 2. N is here. This is greater than 1 by 1 plus half plus 1 by n. So that means 1 by half plus 1/3 plus 1 by n. That value is greater than 2n by n plus 1. So option C is correct. All other options are false. Now we will come to the next problem. The next problem is if you have given two positive numbers, one is x and other is x, two positive numbers. So this is 11, this is 10. You have given two positive real numbers and you need to find out the value of the least value of x plus a by x. The least value of this. So what we will do, we will apply AM greater than GM, or you can say greater than equals to GM. Maybe here x are equal, equality occurs when equals to x. So apply on this two number, you will choose the two number, one is x, this you can consider a1, and a by x you consider a2. So a1 plus a2 by 2. So x plus a by x by 2. This is greater than equal x multiple a by x. So arithmetic mean greater than equals to geometric. Equality holds when x equals to a by x. When a1 equals to a2. So here x is cancel out. So you will see the result ax by plus a by x. This value greater than equal to a. So 2a is the least value because this expression is greater than equals to 2a. So option D is correct. All other options are false. Now we come to the next problem. The next problem is about if x, y, z any real number, then which of the following is true? And you know the formula, you know the minimum of AB and maximum of AB. So you know the minimum if we take here z is less than xy, x comma y, then A or C cannot hold. A and C are false. Then option A and C are false. You will check it easily. You take three real numbers where Z is less than X and also Y, and you will check it easily. A and C does not hold. Now also you know the formula for minimum, and from that case the minimum of AB equals to half A plus B minus mod A minus B. That will be the correct option, and all other options are basically false. So this is the simplest question, that just by using the formula of minimum and maximum you can check if this is true or not. Okay. Now we come to another important problem. If the arithmetic mean of two numbers A and B is 5 times the geometric mean, then the value of A plus B and A minus B. So from this question, what is given? The arithmetic mean of two numbers A, B both are positive is greater than, is 5 times of the geometric, not greater than, is 5 times of the geometric mean. So this is given. And from this information we can write A plus B equals to 10 root AB. Now the question is, what is the value of the ratio A plus B by A minus B? A plus B equals 10 root AB. Now we need to calculate the value of A minus B. So we know A plus A minus B whole square equals to A plus B whole square minus 4AB. So what is the value of A minus B? So simple, the basic formula which we have used 10 standard level. So minus 4AB. So 10 root AB, that whole square, minus 4AB. So that means it will be root 96 AB. So that means 4 root 6 AB. So now we calculate the ratio A plus B by A minus B. So 10 AB, root AB multiple 4 root 6 AB. So that means 10 by 4 root 6. That means 5 by 2 root 6. So this is the value of the ratio. So you can just do the, so you multiple root 6 in the numerator and the denominator. So that will be 5 root 6 by 12. So option D is correct. All other options are false. So the answer is done. Now we move to the next question. Next important question. Question number 14. We will do the answer here. So here it is given A, B, C are in AP. They are in arithmetic progression. A, B, C are in AP. So what exactly mean? Exactly meaning is, so the difference between A and B and C all are same. So B minus A equals to C minus B. So that means B equals to A plus C by 2. Okay. Or you can say A plus C equals to 2. We can say it because A, B, C are in arithmetic progression. Also it is given simple ABC equals to 8. So now we need to calculate the minimum possible values of B. So how will you calculate the minimum possible values of B? Okay. So what we will do, we will the square here, A plus C whole square. We try to eliminate A and C. A plus C whole square, that will be 4B square. 2B whole square. And from that you can write A minus C whole square plus 4AC. That will be 4B square. We are trying to do all these things in terms of B. Okay. So that means a minus CL whole square, this is equals to 4b square minus 4ac. So you just put the value here. AC value is 8 by b. So that means 4ac means 8 by b. You know a minus c whole square is greater than equals to 0. So that means this quantity 4b square minus 32 by b, this value must be greater than equals to 0, since square is of any term is always greater than equals to 0. So that means from this you can calculate b cube minus 8 by b, this is greater than equals to 0. So all ABC are positive. You just multiply on both sides. So b cube minus 8 greater than equals to 0. So b is greater than equals to 8 1/3. So that means 2. So b is greater than equals to 2. So the minimum possible values of b, the minimum value is 2. All other options are false. Okay. So till now we have done 14 important problems from inequality.